topic of this video is fetching and uncompressing files. In particular, it covers how to fetch HTML pages, discusses the difference between text and binary files and how we handle those when we fetch them from the web. And then it discusses how to expand files or uncompress them, such as zip files that are compressed. Finally, we'll go over an example from the Wake County government data download page that combines a lot of these skills in a practical example. GIS data stored on the web may often be zipped into a compressed format. Compressed formats are binary instead of text formats, and you have to handle those a little bit differently from how you fetch HTML or other text formats. So we're going to go over that, but first let's briefly review how we fetch HTML with Python. To fetch files from the internet, we can use that URL lib2 module. We can use it to fetch web pages. In order to do so, we need to import it and then specify the URL of the file that we want to pull down. Then we pass that into URL open and it returns a response. So we call URL lib2.URL open. It returns a file open for reading, and we can loop through that file, loop through each line of that file, and do things with it. Here we're just printing out each line of the file. So what you see there is the contents of that web page being printed out one line of a time. When you download HTML or other types of ASCII text files, that's how it works. You can loop through it. But if you open, say, download something like a shapefile and try to read through it that way, you're going to have trouble. So if you look at the picture in the middle of the slide, that's what a binary file looks like when you try to open it in Notepad. It's a proprietary format that doesn't allow you to read it without some kind of specialized software. So another example of a binary file is a zip file. It's a combination of files compressed into one file. All right, so when you're using URL lib2, you have to know what you're dealing with. If you're dealing with a text file, you can simply do what I've done on the previous slide, which is get that response and then loop through it to read each line of it. But if you're dealing with a binary file, you have to write it to your computer first. It's open for reading, and you can actually save it to your computer. So I'll give an example of that. But one example that we're going to do as an in-class exercise is the Wake County has a data download website. Have you seen that? Grab data from there, which is updated monthly. They've got shapefiles sitting out there on census data, jurisdictions, property, transportation, zoning, highways, and so forth, right? And those are all sitting out there as zip files. So if you want to go in by hand and download it, you can click on it and save as, and then unzip it, you'd have it. But if you wanted to scrape that with a Python script, which you might want to do to keep your data up to date, since they're updating that monthly, you would need URL lib2 URL open function, and then you can write that out. This code from lines 5 through line 11 is grabbing that response. It gets a response, and then it does a read on that open file object response and puts the binary results into a variable that'll hold that binary data. Then we close the original open response open for reading, and then we can open a output file and write it. Notice the WD. Do you Does anybody know what that might stand for?
Right.
Yeah, it's writing binary, okay, and that's because we've written this code to handle a zip file. We run this, that script runs through, gets the file, and writes it out to CTM. So this is the new file. You can see that it was just written. And I could go in there and unzip it by hand. It's got a contents of a shapefile zipped up in there. Just to reinforce this binary, on line 5, we read the contents of the file. And if we print out that variable FTP file, we look at it, it looks like binary contents. Not human readable. Let's go ahead and clear that window. This full path file. Okay. So yeah, so that's the file that we created. This script takes what we did in the previous example and puts it into a function. In this script, the user has to pass in the directory where they want the zip file to be saved and the URL of the data that they want to download. So on lines 19 and 20, we get that information from the user, and then on line 21, we call the save binary method. Save binary, we pass in the URL and the output directory to the function. The function itself fetches the given URL and saves it in the given directory. In the previous example, we hard-coded the link to the zip file. Then in the function version of the script, we had to have the user give the full URL of the zip file. But with Beautiful Soup, we could scrape that page with Python. We can parse it and find all of the hyperlink references in the page using the find all tag with the A specified. And in fact, there's an optional argument used there that says href is true. That means it'll find only those ones where the href attribute is specified. We get to tags. We get a list of tags that are A tags. And then for each tag, what do we do?
Using href and then the...
Yeah, href is an attribute name. Sifting through all of the attributes in each of the hyperlink tags, and we're only doing stuff with the ones that the attribute is href. And if the attribute is href,
Check if it starts with.
if it starts with FTP and
Ends with zip.
and ends with zip. So why do we want to check with FTP? Because the files that we're dealing with are FTP files. So FTP stands for File Transfer Protocol. All of these guys that are sitting out there on the web, on this website, have an FTP as opposed to, say, an HTTP prefix. That's a common way to store files that are out there really just for download. A network protocol for transferring files from a host machine to another. We only want those links where there's a FTP and where there's a zip on the end. Now, suppose we want to find all of the Wake County property files. Then we would have another conditional that would be looking for, what does this do exactly if Wake County in value? It's back from, yeah, go ahead.
Seeing if the word Wake
Seeing,
property is in the name.
yeah, exactly. It's a string operation. Seeing if this string literal is in this string variable, right? If the word Wake underscore property is in the value. And then where value is some string. And then if it is, it's just printing those. So that is the result you get for, or you got in 2012 if you ran it on this, right? You get href for those, the overall, the northeast, northwest, southeast, southwest. What do you do with the zip file once you have it? You can use the built-in module called zip file that Python has, and you can call the extract functionality. You can create a zip object and get a list of the names and loop through the names and do an extract on each of them. If you look at chapter 20 of the book, I have an example that does it the other way you can do it, which is you can do an extract all command. That'll do them all at once, so you can use that function alternatively. Line 23 sets the name of the compressed file that we're going to uncompress. Line 24 sets the name of the base directory that we want to work in, and line 25 is concatenating those two together, and we'll use that as the path of the zip file. It's where we're going to place the zip file. The next few lines are setting the output directory for where we're going to unzip the files. We're going to create a subdirectory called zip out. That doesn't exist yet. We're going to create it. That's what the lines 27 and 28 do. And we call that the destination variable because we're going to place our output uncompressed files there. The last line of the code, line 29, is invoking the function unzip archive, and that is taking as an argument the path of the archive that we want to unzip. So we're using a couple of different synonyms for the file that we want to uncompress. So you can either call it an archive or a zip file or a compressed file, and that archive full name is the full name of the file that you want to uncompress. So in this case, it's the concatenation of the path and the zip file. The second argument is the destination, which is the place where we're going to put the files that we extract. Okay, so the thing that I just did by hand with AllZip, I right-clicked on it and I said extract to this folder. That's what this does, right? It just unzips the file, writes it to disk. This is the workflow for extracting data from a data download page that's composed of HTML. If the page has a set of zip files that are listed there, then you can use this workflow to extract the data. You would need to fetch the download page itself, create the soup object, and get a list of the links on the download page. And then for each link, if the link references a zip file that you want, you could call the fetch zip to fetch the zip file and save it locally, and then call the unzip archive function that we looked at on the previous slide to extract the compressed files. This exercise puts all of these things together in one script. It goes out to the web, gathers a web page, parses the web page to find the hyperlinks within the page, and identifies specific data that are linked to the page, downloads those data, and uncompresses the data. When it's all working, you'll have a shapefile from the most recent data from Wake County locally unzipped on your machine. To get it working, you need to look for the triple number signs in the script. They have comments about what code needs to go there. Add the code, and there are places near the beginning of the script, at the end of the script, and in the two functions that you need to add code to. So look for those triple number signs. Pause the video now and go over to the in-class page to find the Wake URL exercise. You use built-in modules for this in-class exercise, which were traceback, URLlib2, and zip file. And the URLlib2 is for the fetching, and the zip file is for compressing or uncompressing. And use the beautiful soup module. And you had to fill in the blank one of the fill in the blanks was to open the URL for get that, so URL open function, get that response. And then you had to write the contents of the binary file out to the disk. And you had to do a call for the fetch binary and call those correctly and do an unzip correctly. And one tricky thing was, so in this in-class exercise, when you called the fetch binary, it brought the binary file down locally. That was the zip file. So then instead of using URL to pass in here, you had to use the local one, and then you could unzip that file. So that's what this stuff is doing. It's getting the local path, which is just the zip file name plus the local working directory. And then you unzip it. So you get it, save it, and then unzip the local version. Today, when we fetched HTML from the web, we talked about text files versus binary files and how you're going to handle them slightly differently from text files that you seek from the web, which you can simply open and read through them. You have to do what with a binary file? Yeah, you have to write it out, save it locally, and then do something with it. Like if it's a zip file, you can unzip it. Or if it's a shape file, then you can add it to your map, so forth. But shape files, you have to unzip them anyways. And we saw how to use the zip file module to unzip or uncompress files with Python. We combined all of these things in the last in-class exercise, the WakeGov data download example. As an extra challenge, see if you can modify this exercise to download all the street and highway data from this page. The topics in this lecture enable you to programmatically use data warehouses with exposed links, since you now know how to extract the online data for local use.